Okay, let's share my screen. Share screen. Yes, yes. Can everyone see my screen currently? No?
Yeah.
Loading? Cool. Okay, last workshop, and then I am free of creating lesson plans. So I enjoyed it really much. I hope you guys did as well. This is personally, I think, the coolest workshop because we're working on assemblies and motion studies. Wes did send out an email saying we were going to be working on what's it called? Drawings. We won't be doing that simply because drawings, I think, and I believe, are very easy to pick up. And motion studies, for those of you who are joining and continuing with us in Hack, can be very useful when you are manufacturing something or placing design intent behind something. It's the reason why we're going to go over it. So we're going to go over assemblies for the first half, and then we're going to go over motion studies for the second half. I won't give you guys homework on motion studies because that's something that you have to explore more on your own. I would need an entire different workshop for me to completely teach you guys motion studies, but I do want to get you guys knowing that this exists and it is a great tool. So let's continue. Plan of action, right? I will demonstrate the mates after I give you some vocabulary so that you know what I'm talking about. You guys will have some time to practice. There's two practices that you should see in the email that I gave you guys. There is the closet rack one, right? And then there's the jewelry box one. And then we'll go through the motion study. It's just going to be me giving a walkthrough and you guys can follow along. And yeah, and then we'll see from there. And if we have time, I'll open it to discussion so you guys can see. Yes, Sina is next. He has a great workshop. Okay.
Oh
So
yeah. Also, actually, can
yeah,
I we go back to the main room? Can I make some announcements?
yeah, of course.
Maybe
Yeah,
because
of course. Thank you. Remind me again when we're done, because so I can give you enough time for the announcements. But for those of you who don't know what an assembly is, I put Ashley because Annika and I are sharing the slides. But assemblies is imagine all the parts we created, right? So let's say you created a box, let's say you created a lamp, that's that weird vase with the straw that we made. It's putting everything together into a system. Now, how do we put these things together? The glue to this system is called the mates. So mates are the directions we give SolidWorks to tell it how to work. Mates to me were a little confusing because I didn't understand that it was basically geometry. But that's what we'll be going over right now. So as I follow along, as I do the example, I ask of you to follow along as well. Give me
I have one random question. Is there a mirror command for 3D bodies in SolidWorks?
there is. I don't think we touched on that a lot last time, but we touched on it for like 5 minutes. So when you select the mirror plane first, right, that's the first thing that it asks for. I typically orient my parts, my sketches, according to the planes for that very reason, because I want to have accessible to me all the possible options that SolidWorks has to offer. And the best way to do that is when you orient your sketch or your part in accordance to the planes. So after you select that, it can either be a face, it can be a plane, whatever serves to your function. You select the feature. So it has to be a feature. It cannot be something from a sketch. So by feature, it could be like the cut extrude, boss extrude, revolve cut, and whatnot. But that does exist. Were you having trouble using that last time, Oscar?
I am currently trying to do that, and because typically when I mirror, I usually use mirror across a line, but I don't think SolidWorks has that.
I don't think so either when it comes to features. It does when it comes to sketches, but maybe not in terms of features. When I make a part right now, because I do want to give you guys a refresher, I'll try my best to incorporate that. Is that cool?
Okay.
Cool. I'm gonna minimize this here. And if you guys have questions, either react or speak to me verbally because I minimized the little directory of the people who are here on Zoom. Okay, so as you see here, there's a little preview of what your assembly is going to look like. But for SolidWorks specifically, mates are always going to be in your design tree. You see at the top here where it says sketch, it has layout, and now it has assembly. So when we open an assembly file, it no longer has the features tab. It's replaced by the assembly tab. And then it has mates. And you'll notice it has advanced, analysis, standard, and mechanical. That's because there's different types of mates in SolidWorks. The more complicated you need something to be, the more complicated you could choose. So mechanical or analysis or advanced. I typically use standard because that gets the job done. For standard, you have these mates. You have coincident, you have parallel, perpendicular, tangent, concentric, lock, and then two of the ones that you probably won't use often but can come in handy when you need to fully define something. It's going to be your dimension, right, where it says the 1 inch as an example, and your degrees, where it says the 30 degrees as an example. Something that I do want to note, the way you add your mates varies. Sometimes you might want your mates to reflect the operation of the system. So say, for example, you have a toy car that you want to manufacture to 3D prints and laser cuts and whatnot. You want to be able to see if it can move or not, right? Does the design that you made make sense in context of making a rolling car? In that sense, then you would include specific mates that still allow your assembly to move. Other times, you may want something to be completely static, which in that case, you will look for specific mates such as coincident to make something be completely still. In that case, SolidWorks will give you specific indications, and I will show you guys what that looks like as I do my walkthrough. Another thing I wanted to mention is the order of mates and your sub-assemblies. Sometimes the order in which you apply a mate matters. Either that's because it makes something easier to maneuver or because it doesn't mess up a specific thing. If things are constantly flipping in your assembly, because it does do that, right? These are objects that are free for rotation and movement. It can become a little difficult to do your mates and to achieve the specific system that you want. So sometimes you want to be thinking about what would be the best thing to apply first. Similar to how, like, when we're playing with Legos, right? Or like when you're playing Minecraft and you're building something, you should be thinking about what's the best approach to build this as if it was actually here. There are also sub-assemblies. Sub-assemblies are just smaller assemblies within the bigger context of your overall assembly. And sometimes in clubs, you hear that be called as top assemblies. Just a little FYI. The reason why sometimes we use sub-assemblies, it's not absolutely necessary. No one is going to force you to do so. However, like say you're with an employer or say you're, again, an organization that has a lot of parts that come in constantly changing. It's good to keep those things in sub-assemblies because they're like little boxes, part of a bigger thing. And it's easy for you to go in and edit those things and make sure that they're functioning properly and whatnot. Sub-assemblies inside an assembly don't have much difference except that they come in one packet. Does anyone have any questions so far? Does everything make sense so far? No objections? Okay. We're not going to go until your turn. Instead, what we're going to do is you're going to watch me walk through specific mates so that you guys understand what it is that we're working with. So first, sorry, I had to take a breath. First, I'm going to show you guys what it looks like to open an assembly file. So can everyone see SolidWorks on my screen?
Yes.
Yep.
Cool, thank you. Okay, you will notice I have currently the features tab on top of here, which means I am in a part. I don't want a part file. I'm going to press Control-N. And you'll notice that it has this assembly function. I'm going to press right here. I'm going to press OK. I'm going to let that load. I'm going to walk you guys through the interface first, just so you guys can see what it is that I'm talking about. What are you doing? Okay. So to begin an assembly, right, when SolidWorks first opens up, it's going to ask you to add in a specific part. That just means going through your computer, a specific folder, however you have it organized. If it's something that's already open, it's going to show here under open documents. And it'll allow you to select it and put it in. I'll show you guys that in a minute. But for now, I'm just going to press X because I don't want to do that. You'll notice that it says Assembly 6. That's because I've been doing assembly since the morning. And by default, I should mention this. When SolidWorks saves something, it will always be like the name of the file you opened and then the number in the order that it comes in. So let's say, for example, I opened my first assembly in a while, or I have other assembly files that I did not name. SolidWorks is going to name it by saying Assemb 1, Assemb 2, Assemb 3. When it's for a part, it'll be part 1, part 2, part 3, and so on and so forth until you change the name when you save it. Okay, it offers the same things as it does in parts. You'll notice your planes. On top of here, these things remain the exact same way. The only thing that changes, however, is that you don't create a part right when you open the file. If you want to create a part, you have to select a specific setting. But for now, notice that you still have a sketch. And that's because when you're in an assembly, you can still create a sketch within the context of another part. Sometimes that's not always needed, but if you do need to, just know that this is available to you in an assembly. Then we have the assembly itself. You have insert components, which just means you're going to add in a part that you have worked on or that you have saved. It has to be saved. If it is not saved, SolidWorks will not let you put that in because it technically doesn't exist. And if you did updates to it, you should save it first before applying that to your assembly. You'll notice that you have linear components here. You have your smart fasteners. I don't use those. You have reference geometry. Some of you have been messing around with geometries in terms of planes, which is great. I recommend you explore as much of SolidWorks as possible to your comfort because it's really helpful. Exploded view just expands your system into like a bunch of itty bitty pieces. And it just helps you see all the components that are present and how you have put them together and how they work together. You can take screenshots, large assembly settings. It's just changing like the file size. So this is the mate part, right? The mates is where it's going to show you the part that I showed you, which is the concentric, perpendicular, parallel, coincident, concentric, and whatnot. I don't have parts. So because I want to leave those two examples that I emailed to you for you guys to work on your own and so you guys can ask me questions and build that confidence on assemblies, I'm going to make a part on the fly just to have you guys have some sort of refresher as to what we're doing. I'm going to use very basic things. I'm going to CAD very basic things. And I just want you guys to kind of remember that when we make a sketch, we select a plane. We want things to be oriented to the origin. So I'm going to click here. I'm going to mimic the fact that this is my little desk right here. So I'm going to actually create this. Actually have a little cup holder here and a cutout here. So in my sketch, I'm going to incorporate my little cup holder. I'm going to incorporate a slot. Now I'm going to dimension this and I'm going to go ahead and give an estimate that this is probably like 14 inches here. If you already know this part in making an assembly, that's totally fine. I'm just doing this as a refresher if you have struggled before, because we are moving through these things pretty quickly, and I want to make sure that everyone is understanding what it is that we're working with. Oh, why did you expand? Oh, because it's tangent. Okay. This is yay like 1.5 times 2. This is another thing I wanted to show. In your dimensions, you can make these things be equations, and SolidWorks will read that because technically when you add a dimension in, it's adding it as like as a calculator, so to speak. So let's say, for example, you're adding segments of a part and you need to know how long it is together. You can add like the plus sign or the minus sign or the multiplication sign or the division sign. SolidWorks won't trip out about it unless it's like a value that turns to negative, because remember, SolidWorks doesn't read negative values. So I'm going to press enter here. And now it's 3. It's tangent. I don't want it tangent. remember that to delete a relation, I'm going to hover over it until it's orange. I'm going to right click it and I'm going to delete it. It's blue again because it doesn't have a say in terms of like how like the height of it is, right? So I'm going to smart dimension this. Oh, I didn't exit. Not like that doesn't make any sense. From here to here, I'm gonna say it's 3 inches. I actually don't like how big this dimension is for the circle. So if I want to quickly change a dimension, I'm gonna double click on that specific dimension with the left side of my mouse, and I'm gonna select 2 inches, right? And I'll change that for me. Now this slot thing is one that I want to touch on because I know we didn't touch on it often, but for slot, you have to remember it's 3 basic geometries. It's 2 circles and it's 1 rectangle, and then it's the line. So this looks about to be like 0.75. SolidWorks is lagging on me. This is like about 1 inch. This, right. It was over-defined because I had already said that it was going to be 0.75. And if you notice in a slot, it's tangent. So it's the arc and these two are tangent because it follows the endpoints of a line. If I already define how wide apart these lines are going to be, it makes no sense to define the arc. So cool. And then I'm going to make this be horizontal to the origin. Cool. So now I'm going to extrude this. Let me think. I want to include this, so I'm going to go in here and select it. Select this as well. I'm noticing that it's not working, so I'm going to go ahead and select the contours and select that as well until it allows me to do so. Okay, that's included in there. This is like a 1/4 thick. Notice that I have this cutout here. If I don't want that and I want to extrude it upward, all I have to do is select extrude boss space. And remember that you can select the sketch, right? If you already created a boss extrude or whatever feature on top of a sketch, to re-access it, you go to your design tree, click down on this little arrow, select the sketch, and it should allow you to see the sketch again. Delete. I want this specific one. Notice how it's the only thing highlighted. I want it to go halfway. Yeah, halfway to what 0.25 is in one direction. So 0.25 divided by 2. It's not going halfway of what my original extrusion is. But I notice here, if I feel this, that it has something going in the bottom. And I know that I can use my second direction. So I'm going to click that option. And I'm going to extrude out, if you can see it here, like 0.20. I'm going to click OK. And now it has like my little cup holder thing that's here. Okay. I'm noticing that I'm missing this part here. If you want to use extrude cut, again, same thing, access the sketch again. And you would just have to select one more time what it is that you want to use. I want to use this specific area. Right, I want to use that specific area. I want to go inward that way like that. Through all, select OK. Oh, I'm in the wrong direction, apparently. Yes. So now everything's cut out the way I want it to be. Now in your part, I'm going to demonstrate with a cube and then with a circle. Let's say I want to make an assembly now. I can click on File, which is my other alternative. I can make an assembly from this specific part. But first I need to save it. So let's call this board. Saved. So now let's make an assembly. Takes a while. Okay. Remember, I did not close out the board part, right? It's still open. So therefore, it's going to show me my directory. That's an option for me. So I'm going to click on it. Going to slide it over here. And if I click, it's going to show me a preview of it. And now it's there. And now I'm in my assembly. One thing to note about your assemblies is that when you are opening a part, the first part that pops up is always going to be fixed. It's just the automatic thing that SolidWorks does. However, I want these things to be oriented to my origin. So I'm going to right click this. I'm going to select floats. One more time. I'm going to right click the part that's shown in my design tree. I'm going to click float. And now you see that it has this minus sign. And that's part of the directory that SolidWorks has for you. When something is underdefined, as you can check right here at the very bottom, right, where it says right next to IPS and editing assembly, it says underdefined. That means that my part in this context of an assembly can still move, right? It's not static. It can still like interact with the environment. But I want this to be completely static for this specific part. So what I'm going to do is I'm going to click on mate. And now it's going to show me all my mate options, all the directions that I can give SolidWorks. I'm going to click the design tree here. I'm going to select origin. Notice that this origin is like, it's outside of the part. So that means that this is the origin overall of my overall assembly, of my overall dimensionless infinite place. So I'm going to click it. It says 0.1 at origin. And that's another way that you can check that this is the original origin when it has the 0.1, right? Because it's the first point. It's the only point SolidWorks recognizes. I hope you remember that. So now we're going to select down on this part. And now this part has its own origin, right? So I'm going to select on that origin. It's highlighted orange on the screen. I'm going to select it. And now I'm going to see that it says coincident, which is exactly what I want. I'm going to click OK. Now I'm going to press close. And if you check here in your design tree, you'll notice that it no longer has that minus sign in the parentheses, which means that it is now fully defined. I want to check in with everyone. Does that make sense? So far of what I said? Cool. Okay.
So does float just make us like let us know if it's fully defined or not? Or what
I'm
does
sorry,
float
you cut
do?
off. My internet's like really, really rough. Can you
Yeah. Yeah, what does float do? Like, does it just tell us if it's underdefined?
Great question. Floats just releases all the constraints that your part has. So float means, how do I put it? Imagine a body of water. And imagine your part is anchored, right? And it's now like the anchor is to the bottom of the floor. It doesn't move, right? But if I say I want this part to float, I'm essentially releasing it from the anchor, and now it's just floating wherever it is. It's in an arbitrary point of space. Does that make sense?
Yeah, so you use float to like define it in the scope of like the overall. So like it's, or you make it float and then you match the origin with the overall origin. Okay,
Yes.
thank you.
Yes. I just realized what you said earlier. It was to undefine something. Yes, that's exactly right. Float just gives me, it just allows me to put this in an arbitrary place in space that SolidWorks doesn't know.
Thank you.
Good question. Okay. So now I want to find a different part. I'm going to start off with a cube. So basic geometry here. I'm going to insert a components and I'm going to browse because this part is not open. It should open up to this folder that I have right here with your assemblies that I sent out. I'm going to select on this example cube. It's a huge cube. So I'm going to press down on it. notice that I can't move this, right? And when something is fully defined in an assembly, if you try to move this, it'll tell you the selected component is fully defined. It cannot be moved. But what I just selected, what I just put in, can move, right? Because I can drag it around. That's how I know that this is underdefined. One of the things I want to show you guys is the possible mates that I can use. So I'm going to use this cube to show you guys what that looks like. I want you guys to note, if you guys know exactly what mate you're going to put, like boom, 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 right? You don't want it to switch out. You use this little pin. When you press on this pin, it means everything's going to be kept visible as you add in mates, right? And all you have to do is just move your screen around, and it's the same thing. You use this middle button in your mouse, right? So I'm going to show you guys coincident. Let's say I want this space. It's now highlighted in my design tree.
I got a question.
Yes, what's up?
What did the pin do?
Pin keeps this section always open for you. Because mates, if you don't have it pinned, it disappears once you finalize a decision. But when the pin just keeps it there. Does that make sense?
Yes, thank you.
Okay. So now I want that face of the cube. I want it to be sitting on my desk. So I'm gonna select here, that face. Notice that my cube has now rotated. It's a little hard to see because it's a little transparent now, but you'll notice that the face that I currently selected has now flipped sides because I told it I wanted to be on this specific face. And I'm gonna press coincident. And I'm gonna press OK. Now you'll notice it didn't move. But if I move this and I switch it to here, you'll notice that it's sitting directly on top of my board. That's what coincident means in this case. Coincident to the board in the context of the face of the cube and the context of the face, the top face of the board, means they're on top of each other. However, I did not constrain where on the X or where on the Y I want it to be. So let's say I want to fully constrain this. Let's say I want this to be like, I'm going to exit out of mate, for example. And I'm going to move my components for the purpose of this example. If you want to move a component, let's say you want it in a specific orientation, you want to change it in terms of degrees. You're going to click on rotate component. And you're going to rotate this like maybe, yeah, like that, like this, right? It's no longer in its original position. I'm going to select out of it, select OK. I'm going to click my mate one more time. And I'm going to select this edge right here, right? Because I'm thinking, oh, shoot, I want this to be parallel. I want it to be completely on the edge of this table. So I'm going to click this line, and I'm going to click this edge. It's tripping. But let's say I want it to be parallel. If I turn my screen here, you'll notice that these two lines that I've selected, these two edges, are now going parallel. They are in the same direction. So I'm going to press OK. Is it fully constrained? No, because I can still move this around, right? It will always be on top of the table, parallel to the line, but I didn't tell it exactly where I want it to be. So now, I'm not working with anything that can move, and I'm not restricting that option. So instead, what I'm looking for is I want it to stay in a specific place. And we can do this in two ways. Let's say I want it to be completely in the middle of this board. I'm going to select the midpoint, right? And then I'm going to select the midpoint of this specific cube, because let's say I want midpoint on midpoint. I can press coincident, because now I've made it not the edges and not the face, but rather points, because SolidWorks can still register points in your assembly. So I'm going to press OK. So now I can't move this, you see? If I exit out of this, you'll notice that it no longer has the minus sign. And that's because this has now been fully defined. But now let's say I don't want it to be in the center. I want it to be in the corner, or I want it to be a specific distance from a corner of the board. You can check your mates. So select on this bottom corner here. And we are going to look for the mate I just made, which is this coincident one. And you'll notice it's that one because it shows you the points. It highlights it for you. I'm going to select it. And I recommend not to delete your mates, I recommend to just suppress them. Because when you suppress them, SolidWorks is basically saying, oh, I don't see anything, and it doesn't execute it. So for the purpose of this example, I'm going to show you guys how to suppress it. So it looks like this, right? It's right next to the edit feature. You'll notice here on my screen, it now says suppress, and I'm going to click it. Cool. If I check again, you'll notice that it has a minus sign. It is underdefined. And now if I move this cube, it moves around. But I did that because I want to show you guys this other mate. So now you notice here that it has my dimensioning mates. Let's say I want to give it a specific distance from the board. Let's say I want this edge and this edge not to be coincident to each other, but rather a specific distance. Let's say I want it to be like 1/4 of an inch because I'm scared it's going to fall off. 0.25, or you can put a fraction, you could put 1/4, and it reads it the same. Let's press OK. Notice that now it is 1/4 from the edge. And if I move this, it remains in that way. However, it can still move. And if I need to find a way to restrict this, let's say I want this to be a specific picture. If I move this, I notice that it's not restricted from the edges, meaning it doesn't know where to stop. In other words, I haven't told it that I don't want it to like exit out of this table, right? Otherwise it falls off being realistic here. So I can just select another distance mate. I'm going to select this edge, and I'm going to select this edge, and I'm going to go, I don't want you to be coincident. Matter of fact, I want you to be 1/8 from the table. So I'm going to put 1/8. I'm going to press OK. And now if you see here, it doesn't move up and it doesn't move down that way because I made it have a specific distance from the edges. So to recap, you can dimension stuff in assemblies to fully make it like fully static. You can make mates on points, whether that's this corner, whether that's the midpoint, you can do that. You can make things coincident, and you can make things be parallel. The things that I didn't touch on were tangent, concentric, and perpendicular. I want to try and demonstrate to you guys the degrees part. So let me exit out these mates. I'm gonna do the same thing. I'm gonna suppress these things. Because let's say if I'm not 100% sure that I don't need that mate, because sometimes it will give you an over-defining mate, right? Then you might want to bring those back. Actually, let me show you guys what that looks like. So let's say I have this mate. And let's say I bring back this mate. Right? SolidWorks is gonna freak out. Why? Because that first one I made, the coincident one, is saying I want the specific midpoint of the cube be to the midpoint of this desk. But in another function, I told it I wanted to be 0.25 from the edge, which doesn't make any sense. It's either I want it to be coincident or I want it to be the specific distance. It has to be either or. Otherwise, I am either having no solution, it's overdefined, and it doesn't work. So I'm going to close it. This scares me, so I'm going to press suppress. No longer a problem, right? Just be aware that when SolidWorks gives you an error, it's probably because it doesn't make any sense. Not that you think it doesn't make any sense, but rather the execution that you told it to follow, the steps that you told it to follow doesn't make any sense, or it's just overdefined, which can happen in assemblies as well, right? It's totally possible to give it too many commands. So let's make this not be coincident. And now it should still move. Let's see if I can apply the degrees mates. So allow me. Let's say I want it to be, oh no, it won't let me. Because if I do that, I'll be disobeying like this coincident one. So I'm gonna delete this as well. Well, suppress it. I should now be able to move it if I were to rotate it. But let's create a mate. And let's say I want to do this side, this space. Let's say I want to make an angle. I don't want it to be 90 degrees. I want it to be 45. If it'll allow me to do that. Does it? Yes. What? Not letting me. That was supposed to happen, but it was meant to show you. This is probably one is the one that's breaking. Yeah. It was meant to show you that you can also rotate stuff in SolidWorks in your assembly. So let's say you want something to be at a specific angle. You can also do that. You just have to be aware and conscious of the mates that you are putting in, right? Because I knew that coincident was going to break it, but I didn't catch that parallel was going to break it. So that's one of the things that you have to catch sometimes. And if you do make a mistake, that's okay. You can just go in one by one in your mates and press the suppress function. I don't recommend deleting it because that might not be the error, right? Just go in one by one, suppress it, and talk yourself through like, does this make sense? Does this not make sense? If I were to actually build this in real life, what that assembly makes sense. Okay, I'm going to switch from objects of a cube to that of a circle simply to explain what I mean. But as I create this new part, I'm going to ask you guys, can someone give me a summary of what I just explained in terms of assemblies? Or multiple of you, either or, I'm not picky.
I can pick someone.
Okay, go Pracino.
Yeah. Okay, Marco, you go ahead. Marco Garcia.
I feel like
Oh, hello.
Hey.
So basically, you taught us how to first you made a sketch and then you extruded it, a small desk. And
Mhm.
then when you went to assembly, you began to kind of play with it and kind of show us what you can do with it as well as in mates. And then you showed how you can add a different the document to what you're doing, which was the cube, and basically playing around with it just to see what stuff you can make with it. Yeah.
Okay, that was good. Does anyone want to tell me anything specifically about the mates or assemblies? What are some possible errors that can happen?
If you have like conflicting mates, like if you have one that says the midpoints of two things should be matched, and then another one in the future that says like they should be a certain distance away from each other, and then I forget what you did exactly, but like you had them active at the same time, and it give you an error.
Yes, that's correct. There is such thing as over defining my sketch. What about you, Devin? Can you give me a little brief summary of what you were able to get from this example?
so pretty much you kind of just put in, or you just described how to fully define your assembly, given like a select parts, I guess. That's pretty much the overview of what you went over.
Yes, that's correct. Okay, does anyone have any questions so far about what I went over? No, are we good? Cool, okay. So now I'm gonna show you guys specifically the concentric meets. And this is gonna be like one of the last things I teach you from assemblies, because I wanna give you guys enough time to practice and like really get going as to what you're supposed to be doing. So I'm gonna press mates. You saw me make this incredibly long cup that no one's gonna drink from. And I know that I want to make this cup be in my cup holder. So what I can do is I can make it coincident, but I can also use the fact that this is a cylinder. So I'm gonna press this edge. I can either press the edge or I can press the face. I'll show you both. So I press the face, right? And it's a cylinder, so it's highlighting all of it. I'm gonna press this face as well. And SolidWorks automatically knows I want a concentric mate because it's a circle, right? Remember that concentric in its definition means a circle, like the entities of a circle are on top of each other because they're circular. So I'm gonna press okay. But now I'm noticing, shoot, it's going through my part and I don't want it to do that. So how do I fix that? Does anyone have any suggestions as to how I make it be on top of my little cup holder?
Would you have the base of that cylinder and then the top of your cup holder be coincident? Parallel?
Yes.
Coincident?
Yes.
Okay, cool.
That's exactly right. I want it to be coincident. I could also make it be parallel, that is correct, but that's more like adding one extra step. You should be like looking for the easiest way to get these things done, right? But that was a good catch. Thank you, Walker. Okay, so I'm gonna press OK. It is now on my cup holder, which is probably gonna spill over because it's just incredibly thin, but it's now there, right? If I exit out and I take a look at this thing, ignore the fact that this cube is here. You can also suppress parts, and it's the same thing. You just right-click the part in your design tree, and you click the suppress function. Boom, no longer there. Okay. It's underdefined. In this case, it's okay because it's a cup, right? Cups rotate, that's fine. But let's say you wanted it to be like fully defined. I did this to show you guys that you can use your planes. So by that, I'll do the same thing as if I was applying it to my origin. I know that this is going to be the front plane, right? So let's select the front plane of the overall assembly. And now let's go over here to my part. Let's press down on it. And let's press the front plane on this. I want it to be coincident. Don't yell at me, don't yell at me. It will yell at me, that's okay. Or maybe some other plane is gonna work. Either or. The gist of it is, you can select your planes to mate as well. For that case though, it might be a little tricky because you should be creating your parts in context of other planes, right? So remember when we first started in creating our sketches, I demonstrated you guys what the planes look like and how they go in orientation to each other. The reason I did that is because if you create your part, knowing where your planes are intentionally, when you create assemblies, it can be really easy to either mirror something, or when you're making a part, to mirror that as well, or to make your assemblies to each other. In this case, this right plane here of the cylinder, maybe if I select this face here and I want it to be like parallel, now it's fully defined because I can rotate it, because the plane of the cylinder is now has to be parallel to this edge of this board, and so it can't move because it's following my direction. So that's how you fully define that in terms of concentric and mates in planes. The other thing that I can't really demonstrate to you guys because I don't have the part with me is the tangent relation of perpendicular. I'm sure you guys understand what perpendicular means. You've used it a ton in your dimensioning for your sketches. It just makes something 90 degrees. It doesn't go over or under. It's just 90 degrees. And then your tangent, you typically use tangent when it's a sphere or a spherical dome, and you have another object that has to go all around that surface. So think of a wheel. A wheel will have to use a tangent relation if it's on the road, right? Like, let's see if it doesn't spill on me. But let's say this is a wheel. If this is the wheel and this is the ground, if I want to make a relation to it, it has to be tangent because the wheel is going to go on the ground. Does that make sense? Okay. Oh, the other thing I forgot to mention. You guys see right here in this very gray area where it says mate alignment. It just means you can switch directions of the parts. So let's say the part is facing upward, but you actually want it to be facing downward. You can switch the relation into like going up to down. It's the same thing as if we were extruding or making a cut. Okay, before I hand it over to you guys and show you guys what your example is going to be and what the first one is, does anyone have any questions at all? Nope. We're good? You guys ready to give it a try? Okay. Did everyone get the email that I sent? Like right as we started this? Okay. Let me open it up for the your turn part and share my screen one more time. Basically, as I do that, since if you guys don't need me to share my screen, what you're going to be working on is the closet rack, right? You'll notice that I didn't give you any instructions as to what it would take to fully define this. Has a little happy face, but I didn't give you any directions, right? And that's because I want you guys to kind of play around and mess around with what possible assemblies and mates you could be doing. So all of you have the parts, right? All of you should have access to those. Go ahead and open those. I'll give you guys to like, I'll check in on 8:50. And if you guys need more time, I'll give you guys more time. And if not, that's totally cool. But yeah, go ahead and start this activity. And I'll be here to answer any questions should you guys have any. Sounds good? I'll check in on 7:50.
Sounds good.
Recording just so that you can have this a while. Okay.
So so right now I'm trying to, so I was able to get this to be parallel and concentric, but
Uh-huh.
it's not exactly on top of each other.
Okay. Go ahead and exit out of this mate real quick. Can you open up your mates in your design tree? Yeah, okay. Okay, it's because you have tangent on there.
Oh,
So suppress it or delete it, either or. I'm not sure you need parallel here, but can you hover over it? I want to see what you have parallel. Okay, yeah, so here the main things you want to use, and this goes for everyone if you're following along, is concentric and coincident. So what you want to make yes, exactly.
but I was able to get this, but the problem is how do I align it where it fits in the hole perfectly?
It fits in the hole. Yes, for that you would use concentric. So after you use coincident and you press OK, you can select the face of the cylinder and the inside face of what goes inside. Hold on. Press not that face, but the one that surrounds it, right? The one that's like
You mean this one?
yes, that one. And
And
now
this
press the face of the pole. Yes. So now it's
Oh,
completely aligned. Yeah.
oh, thank you. That made it a lot easier. I
Yeah.
was trying to match the bottom face.
Yeah. Thanks for asking the question, Scott. Tal, do you want to share your screen so we can walk through what you were telling me about?
I totally just got so lucky. I put one of the foot bases to the origin, and then I pressed float to the other foot base, and it kind of just put everything into place.
Oh, really? Okay, cool.
Yeah, it just worked out.
Okay, that's cool.
I had a question too.
Mhm.
When trying to even create any mates, for example, it just says the parts are fixed and it won't let me do anything.
Yeah. Okay, so go ahead and go to your design tree. Do you see? Okay, let's first float these. So right click on pole 1. Yeah. Do you see where it says float under the component pole section? Under,
Yeah.
yes. Float that first. And now let's float the rack. So that will move, right? Because it's fixed. So yeah, exactly.
Okay.
And now
Oh,
these
now it
can,
would work?
yes. So now you can mate them however you want. I suggest though that you probably mate one to the origin first. Since rack was the first one that came up, I didn't give any instruction right on what the origin should be. So if you press on mate at the top part,
Okay.
yes. Select, okay, you see where it says assemb to at the bottom of evaluate? At the top. Okay, go to the top.
Oh, yeah.
Almost there. Yes, click on it. You see where it says origin? Click on it. Now click at the bottom arrow of rack 1. click the origin for that specific part. Exactly. See?
Okay.
So now that origin is set up. So now that is defined, not fixed, but defined, which means it won't move.
Okay. Thank you.
Mhm. Does
So
anyone? Yeah.
turns out it didn't fix itself. Over my screen,
Mhm.
it's like all assembled, but the second I move apart, it just like it becomes all disoriented and like weird.
Yeah. Are you able to share your screen, Tal?
Yeah.
Thank you. Okay. Let's take a look.
So
Okay.
something's like right here or something. Yeah,
Let's try something. Select mate, and you're gonna do the whole mating to the origin thing. So
okay.
select the origin of the overall assembly by going under Assemb 1. Exactly. Now click on the foot base 1.
Just like overall.
Click on the origin. Exactly. Okay. We're gonna make this coincident. Press OK. Ah, okay. Do you want to start all over and see how you could do this, or do you want to like debug this, so to speak? Either or, up to you.
I don't care. I'll do both. Which one do you recommend?
Let's take a look at your assemblies. So press cancel on here. Open your mates in the design tree. Cool. Okay, so let's take a look. Can you hover over all of them very slowly so that I can see what it is that they're mated to? Okay. 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 Okay, those make sense. That one also makes sense. Okay. It might be the parallel that's causing an issue. Because you put parallel to,
Should I instead put concentric?
what did you put parallel?
I think
Can you
this was
hover over that one more time?
because hold on. Yeah, look, because you see this?
Yeah.
Well, it's the same one as this.
Yeah, that's exactly it. So don't delete it, just suppress it because I want to see if that is the issue. So at the top, at the top, at the top. Do you see where it says edit, like the one? Yeah, there you go. Do the same for the other one. Now let's try the other mate one more time and see if that was a problem.
Try the origin.
Yeah. Okay, we're gonna try something, okay?
All right.
Add this mate and break all the other ones so we can see which one it is.
Okay.
Did it break it? Okay. You need to select the coincident.
You're right.
Yeah. That's okay. It's okay. It's okay. It's okay. We're gonna see which one it is. Okay. Press close. Oh. One of them. Okay, concentric one. Click on your design tree. So exit out of mates. Now open your mates in your design tree. Suppress that one. Oh, it stopped yelling. Cool. Okay. So it turns out it was the first concentric one. So, okay, what happened was it was probably the order in which you put the mates. Why is it pivoting?
I don't know. I can't move anything.
It's okay. These are underdefined. So now try adding the origin mate. If not, I can do a walkthrough about how to do the,
origin to which one? Should I go next part to origin?
yes. So the first foot that you added, yeah, foot base 1.
Yeah.
Wait, actually, hover over it. Can you click on foot base 1? Just click on it, the name exactly. Okay, maybe select foot base 2 instead. Yeah. So select the origin for foot base 2 really quickly. And see if maybe that's the problem. Hold
Should I break it?
on. No, okay. I think I'm gonna have to do a walkthrough. It's okay, Tal. It's okay.
Right.
It happens. It happens. Someone asked me to upload what the for those of you that are done, let me get a screenshot of the jewelry box real quick so that I can show you guys what that looks like, and I'll add it to Canva. I will show of hands, how many of you want me to do, or thumbs want me to do a walkthrough of this specific example? Okay. Okay. Okay, I'll do a walkthrough. Let me just get a screenshot of the jewelry box and then upload it to Canva if SolidWorks starts tweaking on me, so I can do that for you guys. And then I'll share the link with you guys. It always takes a while to load. Thank you for sharing your screen, Tal, by the way. Okay, SolidWorks is actually doing the most. Let me. Okay, sorry guys, uploading the screenshot now. Okay, let me get this link. Oh, actually, no, the other link. So for those of you that asked to see the, let me rotate. Yeah, it's a very common one. Okay, you guys, if you click the link and you want to see the jewelry box, you should now be able to see that. Cancel. Yes, so if you guys want to work on that while I do the demonstration, that's totally cool. I'm totally okay with it. For now, however, I am going to open another assembly and I'm going to walk you guys through what it looks like to create an assembly from these parts. So give me a second here while I do that.
I had a quick question. If
Yes, what's
anybody
up?
else who's not busy, or you don't have to answer if you are opening anything, but I opened up like one of each part, but I need like the 2 poles and the 2 connectors. I don't. So like, how do you add parts? Can you do that?
Yes, I can show you that. Okay, can everyone see my screen?
I can, yeah.
You can?
Yep.
Cool. Okay, so I'll show you how to do that right now. Let me, please don't trip up, please don't trip up. Cool, okay. You see how I have foot base, pole constraint, pole, and rack, right? I'm gonna select foot base. I'm gonna click open. So now I'm gonna click on this pin up here that says begin assembly because I want it to be there. And so long as it's open, I can select whatever part I want. So I'm gonna select this foot base. I want another one, so I'm just gonna click again. So all I have to do to do that is I can either go in and insert another component individually, or I can keep this open and it will allow me to add as many as I want until I choose a new part. Does that make sense, Adrian?
Yeah, thank you. Ooh, sorry, wait, what did you click right there?
Yeah, I can show you again. Let me click on pull. So originally, this wasn't clicked, right? This top part, you see where it has the pin, the push pin? So I need to click on that so that this remains visible. And so long as that remains visible, I can add in as many parts as I want. So in this case, I want 2 poles. So because I keep it visible, if I click, each click is one addition of the part that's highlighted on my design tree here. So that's how I keep that. Does that make sense?
Yeah, thank you.
Cool. So I'm just gonna go ahead and add all the other components that I need. I know I need a rack, so I'm gonna select the rack. SolidWorks is acting a little iffy. Yeah, the rack here. I'm not gonna worry necessarily about where I'm placing them. For me, that's not a concern right now because I have such little parts. So I'm just gonna go ahead and add all the other ones just so I could have them there. I want this one, and I want 2 of those. Okay. Now, what I do when I'm making an assembly is I first look at what's fixed. I don't want it to be fixed because that means it's there just because it's there, just because SolidWorks said so. But I want to be petty and I want to say where I want it to go. So I'm gonna select float here, and I'm gonna make note that I'm selecting float on foot base 1. The way this is named in SolidWorks is by the order that they come in. So even if it's the same part, it'll have the name of the part and then it'll have the number of its order. So this was the first one that came up, so it has foot base 1. I'm going to select float. Now it's floating, so I'm going to select mate, and I'm going to keep it there because since I already did this, I kind of know where it needs to go. And I'm going to open here my design tree. I'm going to select the origin. I'm going to select foot base 1 and click on that origin, and now it's there, right? I'm going to press coincident. Cool, that's exactly what I want. I'm going to move one of these out of the way because one of these is obscuring my view. And I'm just gonna go as if I'm like envisioning it, like following my eyes. I'm gonna select the pole. My way of thinking, right, is I'm gonna do the one that's probably easier for me to access right now in comparison to later. So I know that the bottom of the pole is probably gonna be a little bit difficult for me to move if I have all these other constraints. So I'm gonna rotate my screen. I'm gonna select this bottom face. Cool. You'll see now that it has face 1, pole 1 in my design tree. And I'm gonna turn my screen again, and I'm gonna click on the one that's already not dimension, but has a command. And I'm gonna click at the bottom part. I'm gonna click the bottom face. If I click this face that's surrounding it, it's gonna trip up because it doesn't make sense to SolidWorks, right? And it doesn't make sense. If I was to be like assembling this on my own, like say it's from IKEA and I'm making it, it doesn't make sense for me to add it from the side. It makes sense for me to add it completely from the top. So I'm gonna select this bottom face. I'm gonna make sure I'm selecting that bottom face. And SolidWorks knows I want it to be on top of it, right? It's making a guess. In this case, I agree with the guess. So I'm going to say yes. But now, similar to what Oscar was telling us is his thing wasn't completely aligned. So I want it to be aligned. And I know that I'm working with 2 circles here, whether that's the cylinder or whether that's the bottom part. So I'm gonna select this surrounding face here, where I could select the edge, either or, it works. I'm going to select the surrounding face here. I'm going to select the surrounding face of the cylinder. And it knows I want it to make it concentric. So I'm going to select OK. That is now fully aligned to where I want it to be. Okay. Now I'm going to move along to this rack, right? Because remember, I'm following my eyes to this rack. I'm imagining as if I'm making a game plan. So I know that it has to be on top of each other, right? Because I know that these cufflinks have to be the ones that are given the support, like the attachment, right? So I'm gonna select this top face here. And then I'm gonna select the bottom face of this rack. So I'm gonna slowly rotate it because it is easy to lose your part. I'm gonna select that bottom face. And I'm gonna make it coincident. I'm just gonna zoom out and zoom back in so you guys can see. I want you guys to notice that while it is coincident, I have not told it exactly where I want it to be. It just knows that in the plane of that face and the plane of this top face, it has to be touching each other, but I didn't say at what instance. So in order to define that, I'm telling it, well, that doesn't make any sense. I want you to be on top of the cylinder. These two cylinders have to be touching each other. So what I'm going to do is I'm going to use the profiles, right? By profiles, I just mean the edge. It's nothing special. Right? And now it's coincident. I could make it coincident. I could also make it concentric. Either or, it works. With concentric, I mimic more of its behavior because it'll move. Right? Which being realistic, if I was assembling this, it would rotate. And that's part of the assemblies that makes it realistic. Okay, so now I'm thinking I want to add the cufflinks now. So cylinder on cylinder, in this case, the order doesn't really matter to me. I could still apply the same thing. So I'm gonna apply this inner radius here, the inner face. I'm gonna select it. And now I'm going to select either or. If I select the top of the rack or this pole, it doesn't matter because of the mate that I made, they are now following the exact same line. Does that make sense? Am I going too fast? Do you guys need me to slow down? We're good? Okay. If you guys need me to re-explain anything, let me know. So now I'm gonna select either or. I'm gonna select this pole because it's the same thing. Cool. Now, what Tal was showing us was the parallel relation and the concentric relation, if I remember correctly. In this case, I'm gonna use a concentric, right? Because I didn't give you guys the hardware. That was part of the challenge part. By hardware, I mean like the nuts and bolts. Because I wanted you guys to realize that when I'm assembling something, they have to be aligned, right? So I know I have to make these cylindrical like cutouts be concentric to each other. So I'm gonna select the interface of here. And I'm gonna select this inside face here. And now it's concentric, right? Because if I were to be assembling this, I need it to be concentric. Otherwise, I wouldn't be like going exactly through and it wouldn't be stable. So I'm gonna press OK. And this still moves. Why does it still move? Because I didn't make the bottom part concentric. So I'm gonna make that as well. Oh, I disappeared. So I'm gonna select this inside face here. It's a little hard to see, but for that reason, you can move your parts, right? Because they're not set in stone. I'm gonna select that. Same thing that I did at the top part. And I'm gonna make it concentric. Boom, now it won't move. The only thing that is moving is this pole because I didn't tell it where I want its plane to be and it's cylindrical. That's a little bit harder to make, but it's doable. So now I'm gonna follow my eyesight, right? I'm seeing that this top part is the same thing as the bottom. So I'm gonna select it and I'm gonna select it. Coincident, but not concentric yet. Let's say I want it to be concentric. Circle, circle. It's not gonna let me make concentric because I chose the faces, right? I need to choose a circle. Otherwise, it doesn't work. If I want to use concentric, let me reiterate. If I want to use concentric, I need to use the circles. So I'm gonna delete this. I'm gonna select the circle edge here. And I'm gonna select the circle edge here because I want to use the concentric mate. Now it's an option, right? Before it was light gray, but now it's there. I'm gonna hit OK. Now, can someone tell me what's the next thing I'm gonna add to my mate? I mean, to my assembly. What's the next thing I'm gonna mate? Either through chat or voice, either or.
Pole constraints.
Yes. So I'm going to use this. And again, same thing as the other one. I'm going to use my concentric, make it concentric. Same thing. I know I'm working with poles, I'm working with circles. So I'm going to use concentric because I want it to be aligned. Right? I'm thinking if I was in IKEA and I'm shopping and I want to think, how am I going to make this? I'm going to think I need to constrain it with the hardware. So concentric, right? I want it to be fully constrained, otherwise this is going to wiggle around. So I'm going to use here, here, and here. You'll notice that they have now become aligned. So I'm going to press OK. Now, the last thing I need is this bottom shoe thingy, this weird looking thing that I did a poor job at designing. So I'm going to press the same thing that I did before. Bam. Bam. Coincident, disappeared because it went to that place, right? But as Oscar had brought us to our attention, it's not aligned, and I want it to be aligned. So what I'm going to do is I'm going to select here, and I'm going to select here, and it's now concentric. So now this is fully aligned. Now, if I go back and I check, these things are not fully aligned. Why? Because technically it can still rotate because I didn't tell it where I want the planes to be. So let's give it a try. It might break, but that's okay, because at least if it breaks, then we know, we can see why it is. So let's say I want the pole, and I'm actually gonna zoom out here because I want you guys to be able to see it. Let's see, front plane. Front plane. I want it to be coincident, right? I want it to be right on top of each other. So I'm gonna press OK. Exit out. Now the pole is fully constrained, right? The one thing that's not constrained is this foot base. But if you do want to make that constraint, you could either play around with the mates, which I recommend doing, right? That's the reason why I was encouraging Tal to like break the mates, because the best way to learn whether or not something works is after it breaks. I don't like it when SolidWorks yells at me, but it is what it is, I guess. So you win some, you lose some. But if you want to figure out what works, what doesn't work, you want to build that intuition about your mates, then I entirely recommend that you break the mates. It's the only way to find out experimenting. So here what I did was I selected the origin from this foot base, right, the first one, to the second one. And you'll notice here that I want it to be coincident. And the reason I did that was because sometimes it'll allow you to align the axis, as it shows here. It might break it. But we're just gonna have to find out. Yeah, so it broke it. So that doesn't work. Sometimes it does. So that's the reason I brought it up, because sometimes you can align your points, right? The same way we did midpoint to midpoint or this corner to this corner in my original demonstration. Sometimes you can do that. Other times you can't, and that's okay. But similar to how we did our defining our sketches, if I move this, it rotates, right? Which means I can restrain possibly a plane. So knowing that this moves, and if I make my planes visible, well, let me do that. No, okay. Show me the planes, please. Unless my SolidWorks is glitching and it's not showing it for me, I'm sorry. But okay, let me hover over the front plane. This front plane right here is possibly aligned to the front plane of this base, right? Because if I hover over it, you see that little square at the very bottom? It's facing the same direction. So therefore, I know if I wanted to make this fully constrained, I don't want it to move, all I have to do is use those front planes. So I'm waiting for SolidWorks here.
Actually, I have a question.
Yeah, what's up?
Yeah, are you using SolidWorks 2024 or 2023?
2024. Some of these
Okay.
things are a little different.
Okay. So if people they're not able to open their parts, and it's probably because like they're on a different SolidWorks version, right? Because typically
Yes.
the older versions not compatible with the newer versions.
Right. Thank you for bringing that up. So to reiterate what Sina has said, I did this on 2024 SolidWorks because at the same time that you guys were supposed to download the serial code that I gave you, I also did it as well because I wanted to give an example to you guys as for like the slides that I sent out. So I'm so sorry. I should have checked beforehand. But yes, since I'm working on SolidWorks 2024, if you're working on an older version, like if you chose not to upgrade to 2024, then you cannot open the parts. But I recommend that you do switch to 2024 if you can, because at least in my clubs, I know we switched over to 2024 and it'll be a little more difficult to get some like design processes done if you don't have access to that. Okay, front plane, and then we weren't a pull one. We were on the second foot front plane here. Constraint. Cool. It is not coincident. So now if I look back, you see that this is all fully defined. Does that make sense? Why is Ryan outside? Did that make sense for everyone? Was it clear? Can I get a thumbs up in the reactions if it was? Oh, let me check chat. Okay. How I lined up the constraint pulls up again. Yes, I can. Okay, so let me, yes, everything should be set. If you notice here, the design tree, you'll notice that in front of the foot, it doesn't have the minus sign. It has the, it has like no indication. And no indication is just the default way that SolidWorks tells us that everything is fully constrained. Good question, Tal. Matthew, I can show you that. So let me go back here and find exactly where it is that's constrained. Okay, I'm gonna suppress it, and I'm gonna suppress it. I'm gonna show you with this specific part. So let's click on mate. So now, for these to be fully constrained, I need to take note of the fact that these are cylinders and circles, right? I'm working with cylinders and circles. So when you think of cylinders and circles, you should be thinking about tangent, concentric, or coincident. I'm not going to use coincident. In this case, it doesn't make sense because what I need this to do is I need this to fully line up because I'm imagining I'm going to put a screw through this. And I can't put a screw through if I don't have the complete clearance, right? So, oh, excuse me. I'm going to select the inside cylinder here. I'm going to move this. Do you see how there's this cutout here that you can see right through? I'm going to select the inside face, which is a cylinder, a circular shape. And I'm going to select the inside face of this cutout here. Because SolidWorks is registering that as 2 circles, which it is, right? To just extrude it out. And I'm going to press concentric, because again, I'm working with circles. I'm going to press OK. And I'm going to do the same for the bottom, because if I don't, it's going to like, how do you lock in the foot bases? Yes, I can. Give me 1 second. Because if I don't, it's like going to wiggle around. So I'm going to select this. And now I'm going to select this. Concentric. And now it should be fully defined, which we can check because it's all there. Someone showed me to show how to lock the foots. Yes. For this first foot, what I did was I went to mates and I mated it to the origin. So I went down here, I select origin, and then I selected the first foot, which is this one. And if I click on it, you'll see this orange box be highlighted. And I select its origin, and I made it coincident. I can't press it because I didn't suppress the mate prior, but this is the first foot. Did that make sense, Jonathan? I'll show you the second one right now. Yeah, so I'm gonna show you the second constraint that I did. The second one, which is the one I imagine you're probably asking about, what I did was I wiggled it around because remember that originally it wasn't constrained. So here, let me suppress this mate first. Yeah. If I move this around, it wiggles, right? But I can't necessarily, I can do multiple ways to like make this be fully constrained. But my main goal was to show you that you can do this to planes. this is just one of the ways that you can do this. So I'm gonna actually select, how else can I do this? Collinear doesn't exist here. But essentially, what I did was I selected the planes. So if I move this around, I know that it's the same foot as the first foot that I had. So I'm gonna say, well, let me look at my planes. I'm gonna open this up, this design tree, and I'm gonna see that this plane and the front plane matches up with the front plane, right? Do you see that? Both of these are highlighted orange. They're facing the same direction, which means if I apply the mates, I know it's not gonna break. It's gonna allow me to do that because mates like to be with each other. So front plane of the foot, front plane of the overall assembly, right? That's a key distinguishment. And I'm gonna make it coincident. Now pressed OK, so that should be set. So now if I try to wiggle it around, I can do it. And you'll notice that SolidWorks gives me that warning that it's fully defined, so it can't move. Did that make sense, Jonathan? Cool, okay. Does anyone else have any more questions about the specific assembly? No? We're good? Okay. Let me pause share really quickly. So now it is 8:30. So we can do one of two things, guys. You can either go ahead and jump onto the jewelry box example, or I can show you guys motion studies. Let me share my screen. Can everyone see Canva on my screen? Yes, we can. Okay. We can do one of two things. I can either show you guys motion studies, or I can show you guys assemblies. Like I can let you guys work on another assembly for the remaining of this workshop. I can talk a little bit about motion studies if you guys want, just so you guys can know what it is that your options are. So motion studies, okay, give me 1 second. Motion studies are basically the way that we kind of predict what our assembly is gonna look like. So you may notice, and the main reason I added this is because I can't tell you what the hack project is, but for those of you that are continuing on to hack with us, it's helpful to have motion studies understood because you can kind of predict the movement of whatever it is that you have to design, or like test what the environment is going to be on it. Not to the full extent to what I'm going to show you, because I, again, would require a whole different workshop to show you guys how this actually works. But the gist of it is you have three options. You have animation, your basic motion, and your motion study. Animation is basically you like if you're an illustrator and you're giving it step by step of what you want it to do. Basic motion is like uses more physics, right? So I can apply a motor, like a linear motor, or I could apply gravity. But for motion study, it's the most realistic. And it's the most realistic because I can apply multiple things to it. And it runs through a period of time, and it shows you like the assembly itself moving. It is a little bit to go through, and you guys won't be given an example. I should preface that. But we can do either or. I can either show you guys motion studies right now and then upload a video about the jewelry box assembly, or we can continue working on assemblies. You guys can ask me your questions, and then I can upload a video talking specifically about motion studies for you guys to review in the Accelerator YouTube channel. So I'm gonna leave it up to you guys. Majority vote, same as how we decided to break our rooms. Put it in the chat if you want to put motion studies, or if you want to continue with the jewelry box assembly. Either or is okay. Assembly, no, okay, okay. Cool, okay. Motion studies, cool. For those of you who wanted, actually I didn't see anyone tell me they wanted to do the assembly, but I can upload a video of that assembly specifically afterwards, as a quick little walkthrough as to what this is. So let me stop my share. And it's gonna be motion studies for the remainder of the time. So we're gonna go nice and slow, and you guys can follow along. For the meanwhile that I set this up, I asked that you guys create a little cube on SolidWorks because I didn't send that one out. So if you guys can go ahead and just take a second to create a cube for the meanwhile that I set up basic motion. Save, please. Cool. I'm gonna get this out of my screen. Okay. Let me just create the assembly file really quickly. And I'll give you guys a second as well so you guys can work through creating that little cube. The cube's dimensions doesn't really matter. I just want you guys to have a representation to walk through what we're going to be doing here. Okay. Let me start by sharing my screen. Oh, sorry, I didn't see the chat. Simple file should be open. Start by opening a part file and create your cube. Create one cube, call it example cube when you save the file. And then once you are done with that file, open a new file, make it be assembly. And then when it asks you to insert components, select the example cube file that you just created. Once you guys are ready, go ahead and send ready in the chat and I will start. Thank you, thank you. Ooh. Okay. 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 I'm gonna give you guys like 2 more minutes because I know sometimes saving files in SolidWorks is a little bit tricky. But the meanwhile that we wait to get more responses on the chat, do you guys have any questions so far regarding motion study, regarding assemblies before we start? Anything you're curious about?
This is kind of just about what you asked right now. We just need one part that's a cube, right? Or do we need assembly?
Yeah, we just need one part that's a cube, and then you're gonna open an assembly file and you're gonna insert 3 cubes.
Okay.
Okay. We'll start in like a minute. Just because I want to make sure everyone is here, give everyone a chance to ask questions if you have any. Okay. Oh, hold on. Do we need someone asked, do we need 3 cubes? Yes. Make no, you're fine. Make one part file be called example cube, and then when you open the assembly, input that file 3 times. Does that make sense? So like if I'm in this assembly and I want to insert a component. Oh, why is he yelling at me? I'm gonna select example cube, and I'm gonna select 1, 2, 3, and so on and so forth. Let's get rid of this one. Yes. Okay. Benjamin, Zachariah, Samuel, Ryan, are you guys ready? Okay, cool. I'm seeing cool. Okay. Okay, so let's start. You're fine. Sina, I asked that you look at the chat in case people have questions or bring it to my attention because it's gonna get a little confusing. Okay, so first things first, when you want to create a motion study, I personally think it's really cool. I was geeking out when I was learning about it, but when you want to create a motion study, the first thing that you want to do is make sure that you have the right inserts. So by that I mean you're going to click on tools here at the very top part of your screen, right? Click there, and you are going to scroll all the way down. So all the way down until you see add-ins. I'll give you guys a second to get there. Cool. So I'm going to click there, and I'm going to check that I have checked off SolidWorks motion. And it should be checked off on this left side, right? I should have this blue check here, and I should have this blue check on startup for SolidWorks simulation. I'll give you guys a sec to see that through. Cool. Okay. I'm gonna press OK. So now, where's the menu? Okay. Look at the top part where it says SolidWorks. Go all the way to the side that it says Tools, right here where you should see my mouse. I'm gonna press Tools. I'm gonna go all the way down until I see Add-ins. I'm gonna click on Add-ins. And you should see add-ins. And this tells you what your active add-ins are. So at the left side, you should see a blue check to SolidWorks Motion. And then at the right side, you should see a blue check to SolidWorks Simulation. Did that answer your question? Yes. Okay, cool. Thank you, Walker. So I'm going to press OK. So now what I want to show you guys is how to access motion study. So like I said, motion study is a good way to kind of see or really show what you want to show with your assembly of your system. So I'm going to select motion study 1. Yes, that's true. So notice here, I'm going to click over here and I'm going to walk you guys through the interface. If we don't get through all of this, don't worry. I will make a video and make sure you guys are like fully getting it. For now, I want you guys to know we're working with 3 cubes for the very reason that I want you guys to understand exactly how it is that we get to this point and the limitations to each animation. So I'm going to click over here. Now that I'm in the motion study 1 tab, you guys should see this. Let me know if you don't see it so I can run through it again. I'm going to click right here on the left side where it says animation. I'm going to click on it, and you're going to see that it says 3 things. It says animation, basic motion, and motion analysis, right? These things, as they vary, as I've explained in the slides, animation is basically you telling them exactly what you want it to do. Basic motion shows a motor, and it shows gravity, right? It shows those very basic things. And then motion analysis shows more like in-depth, real life kind of thing. Motion analysis is a little more tricky to get into. It's more like once you get more used to SolidWorks type of thing, but I'll show you guys what it will look like. How did you get there? No problem. Let me click out of here. This is your default screen, right? Your default screen is always going to be model. You might have accidentally clicked on 3D views. That's okay. You're going to select the next one over, and it's going to be motion study 1. So if I were to give you verbal cue, it would be go to the bottom left corner of your screen. Right next to where it says model, it says 3D views. Right next to where it says 3D views, it says motion study 1. Have animation in basic motion. Is that right for this example? No. Quinn, go ahead and go to the top and click on tools. Yes, no problem, Jonathan. Click on tools. You will see this menu come up. I'm giving you a second, sorry, I didn't mean to sit there in silence, but we're gonna go all the way down and we're gonna click on add-ins. So we're gonna press it. And then we're gonna click on SolidWorks motion here on the right, to the left, and then SolidWorks simulation to the right.
Oh, my bad. I thought I had done that last time you explained that.
No, you're fine. Does it work now?
Yeah, I got it.
Okay, cool. Okay, so now that we're all in motion study 1, welcome. This is animation, this is basic motion, and this is motion analysis. You won't notice the immediate difference right away for the reason being that it only changes the functions that you are allowed to use, not the interface itself. So right now I am at 0. I have 0 mates ongoing. But the one thing that I do want to point out is that if you did want to add mates to your specific animation, you could do that. The only thing is that it won't transfer over to the overall assembly over here in your design tree. Right, and that's very important to note because if you make an assembly and you're thinking you're editing your actual assembly file, but you're actually an animation, basic motion, or motion study, it won't save. So keep that in mind. So now I want this to be, let's put this at 5 seconds. So what I'm going to do is I'm going to go over here to this top part of half of the screen, and I'm going to click on 5 seconds. Right? These things that you see here, Animation Wizard, we're not going to go into because that's not the focus right now. Leave on auto key, we're going to use it. Motor, your spring, you have a damper, you have a force, you have a contact, and you have gravity. Notice the apple, you might get a flashback from the emoji story that I did. That's where I got the idea. And then you have motion study properties. So I'm going to click on that because I want to show you guys first of all what this is. And because it's animation, right, you notice you have basic motion here in your design tree, and you have motion analysis, and you have general options. I'm going to click away on general options. Animation is showing you frames per second. So it just, if you want it to run more smoothly, then you up the number of frames per second. If you want it to run more staggered, bit by bit, then you lower the number. It just shows how smoothly you want things to run. So I'm going to exit out of it because I'm going to keep it that way for the meanwhile. So now, this is the way it works. I'm going to change the second, and I want you guys to follow along. Notice here how it has 0 seconds, 2 seconds, 4 seconds, 6 seconds. And that's because these things are time dependent. So if specifically in animation, let's say you have a presentation or you want to show an employer how something works. You want to show exactly how an assembly moves. You're going to move this frame by frame if you want it to move in a specific way. It's tedious, I know, but for animation, that is its purpose. I am going to move this 1 second right here in the middle. And let's say I want this to move, that's fixed, sorry, here, and I want this to move here. You'll see this green bar. right next to example cube 2 and example cube 3, those are the components that I moved. The reason those green bars are there is because it is telling me that it has moved. It has an operation going. So if I were to press run in this operation, it will move in that way. Now let's say I want to go for the second. For the second 2, I want it to be in a completely different area. So I'm going to move this over here, and I'm going to move this over here. Again, notice those 2 green lines. Let's say I want this to run. It moved. It's an animation. It actually moves according to what you tell it to do. Now notice it moved like really like staggered and all that. Let's say you don't want that. You go back to your motion study properties, right? I'm gonna click on frames per second. I'm gonna up it. 100. Why not? And I'm gonna run this again. You see how it's moving a lot smoother? That's how this animation thing works. And it makes a little chime. I don't know if you guys can hear it, but I personally like it. I'm gonna stop here. Does anyone have any questions? Throw them in the chat, say them out loud. Either way, I got you. Does anyone need me to go through what I just did? No? We're good? Okay. What do you alter the frames per second? Yes, good question. So notice here where it says animation, I'm gonna travel in the same longitude all the way to the right, and you'll see this gear on top of 14 seconds. So I'm gonna click on it, and you'll see animation specifically, and you'll see frames per second, and you should be able to change it there. Let me check the chat. Keyword, how you got the green line and the 10 line again? Yes, I can. Okay. Let's move this. Let me exit out of this. Ooh. Got it. Yeah. So let's move this here. If I move this, I don't want it to take this long. Sorry, guys. I'm impatient. But let's say I wanted to run that, right? To get this green line, I need to make a movement. So first, what you have to do is move this gray bar that you may notice. I mean, not bar, a line. It's currently at the 2 seconds. I'm gonna move it up 4. And I'm gonna move this box. So let's move first this cube, this box extrude 1 of example cube 3. And I'm gonna move it over here. You see how it has that green line? So in other words, if I want this green line to appear, I'm gonna move this gray line to the next second, right? Because it's essentially the same frame. And then I'm gonna move the part wherever I want it to go. So let's say I want it to go completely opposite ends. I'm gonna make this now move all the way over here, and that green line appears. Did that make sense? I'm sorry, I don't remember who asked me the question. Let me check. Yes, okay, cool. So now let's run the animation. What does this look like? Exactly. Let's run it again. Boom, it's following the exact same steps that I told it to follow, which means animation is exactly doing what I told it to do. Did that make sense? Let me check the time. We're at 8:50. Okay, we're running a little short on time. That's okay. I just want to make sure you guys are understanding, because more than likely, if you're on the hack project, you're more than likely to use animation if you want to show the rest of your team how maybe you're thinking of something or how a design is. So does this make sense so far? I know we're only using cubes, but I just want to make sure you guys are understanding what we're doing. Cool. Okay. So now, thank you guys. Thank you. Okay. So now what we're going to do is I want to try and show you guys mates on here. So I'm actually going to put this back here. Put this back here. If I remember doing this correctly. Put this back here. Yeah. So I'm moving all of this back to this first part. Let's make this. Ooh, no, go back. Go back. Let's press Control Q. Okay. It's basically reset everything now. Is this used to kind of like simulate moving parts in a system? Yes, it is. So like I said, an assembly is a system, right? And let's say you want to demonstrate how something moves or how something could potentially move, then you would use animation or you would use basic motion or motion study. The one thing I want to point out is that with animation, you can use, no, animation, you just change the position. If you want to change, what's it called? Contact, you want to see these things interacting, then you would use motor and contact, but that's in motion study. So let me go ahead and show you guys how I would go about in making this, what's it called? A mate. So I'm going to click mate here. Is it going to load? Yes. Okay. I'm going to click this face. And now I want to make multiple, so I'm going to select this one. I'm going to select this space. And it's going to show this. That means, do you want this to be your initial frame? I'm going to select yes, right? And this is also an indication, and also I'm going verbatim by a video that I learned. This is where I watched it from, but it's basically telling you that you are making a mate based off of an animation in SolidWorks, right? So if you didn't know prior that you were making a mate in motion study, now you know. But we're going to press yes for this example. So let's press yes. And I want to select this other one here. So I'm going to select this face. Cool. I'm also going to press yes. And I'm going to select, cool, that's exactly what I want. Now, I'm going to select this top faces here. Top, top, top. Yes. I'm going to select yes. So sorry, I got distracted. Let's say those mates are there. If I try to run it, what's going to happen? Virtually nothing. Why? Because these are aligned and I put them all at the 0 mark, which means this is its initial place. If I wanted it to be in this 2-second place, right, then I would have to add in the mates the way I did here, right? But it doesn't work because I put them all in the initial place, which means that essentially what I told animation to do was I made these mates at the 0-second mark, right? Which means that I want you to start at this specific mate, which is wrong. I wanted it to show it making a mate at the 2-second mark. So if I wanted that to happen, I had to have my blue mark, my gray mark here at the 2-second mark and then apply the mates. Sorry guys, let me check the chat really quickly. So let's say, for example, I suppress this, right? Just so I can show you guys what I meant. And now it's changing, right? Because I'm telling it that at the 2-second mark, I don't want this dimension to be there. So we suppress. And now if I play this animation, wait, did you see it? I don't even know if it's that. Hold on. It's unsuppressing there, right? But let's say it's unsuppressed, right? I no longer want it to be there. And I'll move it up to the 4 seconds because it no longer has that. Notice that it's still gray here in my design tree. If I move these like around, it technically will allow me to do that because I took off the mates that I originally had for the animation. Right? So let's play the animation. Did that make sense? So let me break it down. At the 0 mark, right? At the 0 mark, you'll see down on my mates, I had my local coincident, right? Which means that my initial starting point is where they are all present with the mates. Now let's go to this 2-second mark or the 1-second mark. No, the 2-second mark. At the 2-second mark, I told them I no longer wanted you to have that mate. So this mate is now suppressed. If I go up to the 4-second mark, I'm telling them that I want them to be in a completely different position. And it knows that because I moved it at this specific mark. Does that make sense to everyone? We're about to wrap up, so I want to make sure this makes sense. Can I get a thumbs up if it does? Okay. Thank you, Kevin. Okay. So now that's the part, right? Now let's say I want it to like come together at a specific part. Let's say at this point I want to unsuppress these mates. So I'm gonna unsuppress it. Oh, actually, let's move it up a second. To 5 seconds around there. Right here. And I'm gonna unsuppress it. Suppress, unsuppress. It's a little tedious because again it's animation, but unsuppress and unsuppress. Okay, now my vision is I want these to come together. So what I'm gonna do is I'm gonna go up to 6 seconds and I'm gonna create another mate. And this time I'm gonna use the distance mate. So I'm gonna press mate here. And I'm gonna select this face. And I'm gonna select this face. And I'm telling it, you know what? I want you to be, yes, that's okay. I want you to be the distance of like of 1 inch from each other. Yes, that's okay, that's okay. So like 1 inch, right? Boom. And now let's say I want it to be also 1 inch from each other here. Oh, actually that doesn't work. Right. Hold on. Let me fix that. This needs to go. Let's press OK. Now let's add another distance mate, which has to be from here to here. Sorry guys, it's a little small. But let's say I want this distance to be 2 inches instead. We're gonna edit this to 2 inches. Cool. So now if I go here and I show it to that, it's gonna do that exact same function when I run the animation. So let's run this animation real quickly. Unsuppressed it. Now it's moving. It's moving. And now it goes back to that 1 inch dimension that I had put. Does that make sense? Oh, so sorry, I didn't see the chat. Okay, cool. So that was animations. It is 9, so I can't go over motion study, which sucks because it's super cool. But maybe I could. Low key. But Wes might get mad at me. Hi, Wes.
Hello. Yeah, we should probably close up the session. And so maybe you want to say your final words and then come back to the main meeting room. I have a couple of announcements.
Yes, I will do that.
Thank you.
Okay, so guys, so sorry we didn't get to go through motion study or basic motion. I'm saying it all wrong. Basic motion or motion analysis. Okay, I froze. I'm so sorry. We didn't get to go through basic motion and motion analysis, but that's okay. I will post a video. Was this something that you guys were interested in? Is it something you guys like want to know more about?
Absolutely. Thank you.
Yeah.
Okay, that's good. So I did choose the right concept. Okay, cool. Yeah, cool. So I will be making a video about these 3 motion studies and giving it to you guys. And I will also be making a video about the assembly for the jewelry box in case you guys were confused. That one has a lot more components, and I did that because I wanted you guys to practice kind of working through that and your thought process behind it. Really quickly, do you guys want me to give you feedback on your assemblies? Go ahead and say yes or no in the chat.
Yes.
Yes.
What does feedback mean?
What does feedback mean? Feedback just means like you post a picture or like a picture with Quinn, to answer that question. Yes, it's Ryan. It's to check if it's right or not, overdefined or not, and just so like for me to do some check-ins. Jamboard. I'll think about that. I low-key didn't like the Jamboard method. I think it'd be better some other way. I should have done a Google Classroom low-key, but that's on me. But I'll think about that. I'll keep you guys updated. Point to answer your question, it's meant to be completely static, so you cannot open it. It's not a dynamic moving assembly. So don't worry if you didn't get to open the drawers. It's totally fine. Yeah. What's it turning me up? But okay, I will post a video about the motion studies. I will post a video about the jewelry assembly box. And check-ins just mean me getting a chance to see your progress so I don't have to do like check-ins afterwards. Also, would you guys be open to an office hours for all of SolidWorks? Yes?
Yeah.
Yeah? Okay. So I will try and set that up. I know some of you guys are still taking classes, I believe. So I'll send out a when to meet in an email and you guys can like answer that and then we can set that up. Not this week though, because you guys deserve a break. SolidWorks is a lot. But yeah, let's go back to the main room. You guys did awesome today. Good job, guys.